In difficult times, it's usually a good idea to do a bit of a retrospective in a sense that you want to understand what is it we're doing, why are we where we are, what are the prospects. If you want sort of a reinforcement learning analogy, understand your trajectory and then do the prediction. So this is what I'm doing now. And we've had a pretty rough start of the year. We're down 10% for the year. The market's flat. It's definitely not encouraging from that perspective. But having been invested in Tesla for over a decade, I think that's nothing new either. And we just have to deal with this. But we've questioned recently whether we should reduce our position in Tesla. And the reason we've questioned that is partly because Tesla is um, having some, let's say, they're not delivering as we had planned it, which is not a crime at all, but it's still a concern that we have. And then there's also other opportunities. So we kind of have to weigh that. And the purpose of this podcast series is to give people a sense for what it feels like to run a hedge fund. And this is really where the rubber meets the road. When you're invested in something, when your portfolio is exposed to certain things, and then you have doubts about that, and then you have other opportunities. So you have to think, okay, do I change? Do I, do I move, or do I stay put? And I have to say, one of the biggest problems in the hedge fund business, as a human running a hedge fund, is trigger happiness. Acting is relatively easy. It's expensive, but it's easy. We rarely see the cost, and the cost of action is, one is transaction cost, but it's also missing out on opportunities. We've worked on Tesla for over 10 years, and for us now to switch, let's say, into Synopsys or Microsoft because we think they're good ideas, it could end up being really costly, maybe 5 years from now, because we might be missing out on an opportunity that we have a very good grasp on, and we might be making or losing money, or maybe getting lucky and making money on these other things. But the uncertainty, the risk-adjusted return is not justifying this. So my point is, this is really reinforcement learning 101, right? Exploration versus exploitation. What's the greedy action? In terms of where we are right now, we are very greedy. We have 96% of our assets in Tesla. It's worked for us, so we're very greedy. We keep doing the same thing. Exploration means we have to look around what are other opportunities. Now, to be clear, we are doing that. We are actually exploring other opportunities within the context of the theme that we're invested in, which is AI. Okay, so we are invested in artificial intelligence as a whole. This is the idea. This is where we spend our time. So in that sense, we're like a grad student who is interested in AI. Look, when you go to Berkeley or Stanford, you can't just study everything, right? You can't be an English major, play football, and get a PhD in reinforcement learning. That's not going to happen. You have to focus on something, and the same applies to a hedge fund. Like, we're in the knowledge business, so we're similar like a grad student at a university. We have to focus on something, but within that something, you can do exploration. And that's what we're doing. So, and this is what this particular episode today is about. So it's the exploration. We're looking at what is it, what is our thesis? What are we interested in? What is out there that, to our knowledge, is going on? And then is there congruence here? Are we hallucinating? Or are we on the right track? And if not, what should we do? This is not even on podcast. It's January 13, 2024. This is Krim-Delco. It's a Saturday. There's no update. For the year, we're down 10.2%. Markets up 20 basis points, round performing by 10.4%. So, and this is the reason why we're having this episode. It's a little bit of an emergency episode in one sense, because we're having a very bad start of the year, driven by Tesla. and we are questioning whether we should be changing our portfolio structure. Now, I'm not going to talk too much about portfolio allocation and the other ideas that we have. I just want to say one thing. Whenever you're talking about your portfolio structure as a portfolio manager, the one thing you're going to do is you're going to have to consider the opportunity cost of what you're invested in. So one thing is the return that we expect to make, which with Tesla is something around 25 to 30% annual return in the next 4 years. This is what we expect. So we expect a 3x by 2027. With Tesla, we expect Tesla to be about a $2 trillion company and making 25 to 30%. So if you have $1 million invested today in Tesla, you expect to have $3 million by 2027. That's the idea. Now, can we do better elsewhere? Having this in cash, having our money in cash certainly is not going to make us a 3x return. Having our money in Microsoft probably will not do it, but it could be. So this is the kind of thinking that you should have, and this is where I'm going to stop. And I really want to talk about the actual fundamental ideas, the thesis, and the scientific and technological developments that are driving our portfolio. To me, this is more interesting, and this is what I'm going to talk about. So what I'm going to talk about today is I'm going to talk about two keynotes from a conference that is, I think the name is something, Computer Vision and Pattern Recognition, CVPR. It's a conference that happens in Vancouver, I think annually. And the keynote is Sergey Levine talking about offline reinforcement learning and self-driving car technology. I'm going to talk about Ashok Elluswamy, the head of AI or head of self-driving technology at Tesla. And then I'm also going to talk about an interview between Sergey and Pieter Abbeel. And the reason I'm doing this is because I think it's good to be founded in the science, and it's also good to understand the actual technology that is driving our portfolio. In other words, what Pieter and Sergey are doing is not directly driving our portfolio, but it's certainly relevant for our portfolio. That's why I'm looking at them. And then Ashok, of course, is driving the actual technology, which is driving the valuation of Tesla, because we believe that full self-driving technology as a whole, and then applications of that even outside of the car, i.e. in particular the robot, could be big drivers of valuation. So let's talk about Sergey's keynote. What is offline reinforcement learning? What is behavioral cloning? How is it different? And what's going on here? So I think Sergey, the reason I like Sergey Levine is because he has a certain depth and understanding of the field that resonates with me. He's also, I think, a very prolific researcher in a sense that he has been able to find the sweet spot between prolific and having a high H index. In other words, he's not just doing the science for the science. That's my point. I want to leave it at that. This is not about Sergey. This is not about science. But I just want to explain to people why I'm interested in his particular work versus others. And I think the same thing applies to Pieter. That's why I like both of them. And I just follow them. And I could be wrong about this. And there's definitely other good people that I've met at NeurIPS and in particular NeurIPS, which was sort of my big entry into the space, talking to people there and understanding how they think. Chris Ree, for example, also very impressive. Different field, completely different. So let's talk about Sergey. What is Sergey saying? So behavioral cloning is, in a sense, that's what Tesla has been doing for years, okay? It's you're driving a car, you're collecting video data, and then you're teaching the robot based on that data to drive a car. That's behavioral cloning. What is offline reinforcement learning? It's very similar, but there's one fundamental difference, which is reinforcement learning is a decision-making technology. Behavioral cloning is a predictive technology. So you look at what people did in the past, and now you're predicting what you should be doing given what you know people have been doing in the past in similar situation. Reinforcement learning is an active decision-making process where you use algorithms such as, for example, deep reinforcement learning, where you where you try to learn how to reward the robot, how to nudge the robot through rewards towards actions that have a certain outcome, a certain goal. For example, in the case of the car, to get from A to B without killing people and doing all other things that they shouldn't be doing. Now, here's the key, of course. If you want to do this, if you want to program a car to drive, you could do this explicitly, right? You could tell the car what to actually do, but that's very difficult because the environment could be so different. And therefore, you want to find a data-driven approach. And this is what reinforcement learning could be eventually doing. And I think it's a subtle difference between behavioral cloning and reinforcement learning, but I find it really fundamental. And I think Sergey's talk reinforces the idea that there could be some application of reinforcement learning algorithms within the self-driving car space. But in general, it's the same problem, which is when you have a decision-making agent which is learning on policy, so learning while it's doing, you can't do that in the real world because it's too dangerous. So you have to find ways to teach the agent how to behave and then let it go out in the wild. And this is what Tesla has been doing for years now, right? It has been teaching the car while driving the car, and it's been has been using us customers who drive the car. It collects the videos. It also uses what's called shadow mode, or I'm not sure if they're still using it, but they've been doing a certain trick or hack where you're driving the car and there's a software in the car that is parallel to you driving, pretending to be self-driving the car and making predictions in milliseconds about what it should be doing next. And then Tesla as a company can learn from the discrepancy between what that shadow mode would have predicted and what you did. And that's kind of where they can then learn also how to drive the car. So this is, in a sense, what they've been doing. Ashok's presentation is about 6 months old, doesn't mention that. I'm going to go through Ashok's presentation in a second, but I'm just mentioning this as a side note. Back to Levine's talk. So behavioral cloning is very similar to offline reinforcement learning in a sense that you're looking at data from the past, from people that have been doing the driving, and now you're trying to learn how to drive. The difference between behavioral cloning and offline reinforcement learning is that within offline reinforcement learning, you're going to use that data, and you're also going to design a certain algorithm that uses reinforcement learning, in other words, a reward system to guide the actions of the agent. And the way you're going to design this, is you're going to use a reward function design mechanism that is embedded, that is grounded in the data from let's say in this case from the driving data. Sergey talks about different applications of offline reinforcement learning, not just self-driving. He talks about, let's say, power grid management. He talks about drug prescription, any kind of decision-making process, in essence, could be run by reinforcement learning. Reinforcement learning, I think, has had its ImageNet moment with AlphaGo and AlphaGo Zero. And that's where this is coming from. I think people don't talk about it enough, but it's AlphaGo Zero that, in my opinion, was a much bigger event than ImageNet or GPT-3 or 4, whatever. The reason it's big is because when AlphaGo Zero beat the world champion in Go, it was trained on a self-play mechanism without any explicit rules. And this is the holy grail. This is what Tesla is trying to achieve with end-to-end learning. And therefore, I think reinforcement learning as a decision-making process. So there's a different. ImageNet is about classification. So classification is a problem that stands on its own. Like you can have classification, you can deal with classification. You can have classification problems all day long. Is this a cat? Is this a house? But this is not the same as decision making. Decision making is, should I turn left or should I turn right? Should I increase the power supply or not? Should I use my substation here or there? Should I prescribe this particular patient this drug or that drug, and in what quantities? Those are decision making problems, not classification problems. And if you look at Ashok's presentation, I'm going to Ashok's presentation. Ashok talks very specifically about three things. One thing is the classification problem, okay, which is based on computer vision. He's talking about occupancy networks, and he's talking about how they see the world, which is AI-driven, neural net-based stack that is trying to represent what the car is seeing. Houses, cars, trucks, pedestrians. The planning is different. The planning is now, this is where the offline reinforcement learning or the behavioral cloning kicks in. The planning takes into account what it sees, and now it has to make decisions. Now, Ashok is not overly verbal on that one. So this is definitely something that is open for conversation with Tesla, whether it's with the IR or hopefully at an AI day, if they ever invite me again. The idea is that we have a decision-making agent that needs to make decisions. And Ashok and Musk have spoken about this, that it's end-to-end. But how much end-to-end, that remains to be seen. But if I combine Sergey's work with what Tesla is doing, there's a lot of congruence there, even though I'm not even sure if he ever worked there. I know Jitendra Malik's work. There's some people of Jitendra's lab that actually went to work for Tesla's humanoid robots. So there's some overlap there. I'm not sure about Sergey's work. But there's, from a fundamental scientific perspective and a technology perspective, there's a lot of overlap. Because what Sergey is trying to achieve is he wants to build a robot that can learn on its own. He wants to bootstrap a robotics fleet of robots that are data-driven with no explicit programming, end-to-end learning, learn how to do things, pick up stuff, move around, whatever they do, and then use that knowledge to bootstrap a whole slew of robots that can do even more and more. He talks about this in his Robot Brains interview with Pieter Abbeel, where he says that after, I think it was his gap year before he started his professorship at Berkeley, where he worked on a robot at Google, and there he wanted to build a robot that if you let the robot just do stuff, let's say, clean a room or organize a room. I don't know exactly what he was doing, but let's say you put a robot in a gigantic warehouse with like lots of mess, and you give it certain, you bootstrap it in a way that you tell it, okay, look, I want this thing to be cleaned. And then you just let the robot keep doing. The question is, if you let the robot do it for longer, will it get better? Okay, these are baby steps now. Okay, if we have a data-driven end-to-end learning type system, you would predict that the robot gets better over time. And he did that, and he concluded that that was the case with that particular algorithm that he used. So this was, a couple of years ago. I think today we're already at a point where we agree with that. That is the point to go. That is the way to go. So Ashok, Now let's talk about Ashok and Tesla. This is where the rubber meets the road for us, because whatever Sergey is doing and Pieter at Covariant and everybody else, and it's not really going to help us directly. What helps us directly is what Tesla is delivering. Can they monetize their FSD? And for that answer to be answered, we need to understand what FSD actually can do and how it's doing it and how good it is. Now, in Ashok's presentation, it becomes clear that there's a lot of emphasis on the representation of the world and maybe not so much emphasis on the planning. So the planning of how the actual robot drives around is not as well documented. I believe that's also because Tesla is still a relatively novice in that particular field, because the science is not there yet. That's why I'm connecting this with Levine's work and Pieter's work. There's a lot of work in reinforcement learning, offline reinforcement learning, problems in offline reinforcement, in particular, what's called distributional shift problems. So you see, if you have a car that is driving around and you're using reinforcement learning to teach the car on policy how to drive, you will have an issue, which is, let's say, you want the car to explore options, right? You want the car to be creative. And you could end up in a situation where the car is going to do something stupid. You don't want that. How can you, I mean, this is a fundamental question, right? How can you induce an agent to do something that is better than what it's been learning from the data? This is a fundamental question that, in my opinion, has not been answered very well. I think the answer to that question is, well, you can do that through iteration. And the answer is also, it's going to happen, but it's going to be random. It's not going to be in a deterministic way. And you can't risk randomness in a self-driving. So there's a little bit of a risk there, a little bit of a tricky situation where if you want exploration, if you want a creative AlphaGo zero type solution to a problem, you can do that, but you can't kill people on the way of doing that. So let's say if a car decides to avoid, let's say, an accident, and it does that by, let's say, crashing into somebody's car while they're not in the car, so that way it avoids the accident, that's not a good idea, but it could be a very creative solution to a problem. I'm just coming up with my point here is that you can't risk, you have a fundamental problem here, right? You're learning based on data, and now you want the agent to do something which is not in the data. How do you do that? And again, there's lots of work on that. I'm not the first to mention this in any which way, but it's a problem to be worked on. Now, one solution is to let exploration and reinforcement learning to not use that. And I'm not sure that's the thing. I'm not sure Ashok hasn't spoken a whole lot about the planning process. So I'm not sure where they stand with that. So my conclusion here is that I think the science is incredibly interesting. There's a lot of work also, by the way, from NeurIPS that I'm going to have to discuss in a different episode, just with respect of time. There's work on again the reinforcement learning problem, the offline reinforcement learning problem. There's work on transformer technology and architectures used in robotics, in particular in let's say self-driving. We have lane prediction, which is a canonical problem that has been tackled with transformer technology. So there's a lot of that, but this particular episode really was just to ground myself in the science, see what is going on there, and then see how it translates to Tesla. I would say my main conclusion is that I feel like Tesla is, in a true sense, an engineering company. They're not as thorough and deep and quite frankly open as scientists are. So there's a little bit of obscurity there. The good thing about Tesla is that, let's say, in the presentation that Ashok gave, a few questions came up, and they were typical, excuse my French, bullshit questions. You know, oh, are you using which data set are you using to validate your data? MSig or this SIG? No. Or are you using ResNet, or are you doing adjusted ResNet or RegNet or blah blah? Like posturing, bullshit. You know, recently I was in a seminar. Somebody was talking about, you know, this is tangent, but you know, somebody's talking about the advancements of Amazon Nitro, and then there's a question. Well, what kind of tape out nodes do you use for the chips in different generations? I mean, bullshit question. Just using jargon, trying to signal that somehow you're smart or what? It's human stuff, bullshit, not necessary. We have the same thing here. I think Tesla, through the leadership of Musk, has certainly one of the things they've been doing is try to get rid of all this as much as they can. So my conclusion is that the science is there, the technology is there, Tesla is doing it. Some of the obstacles are really deep. In particular, applying reinforcement learning to the self-driving car problem, to me, it's not clear that that's going to work. Again, because how can I allow exploration in a self-driving situation on policy? Like, off policy, yes, but on policy, I don't see it. I mean, it's just too risky, right? But then maybe I also don't understand exactly where the science is. Maybe there are some solutions, gating, for example. So you can, what that means is you can kind of learn through meta parameters which actions are better for exploration versus others. Abbeel has a paper that I'm going to discuss in the NeurIPS context, where they encourage exploration intrinsically by eliminating very high value differences between states. There's some work on that front. Again, that's definitely something I think I need to do more research on. But I think my feeling is that there's some interesting work being done, and that there's some interesting applications ready to be deployed. This I would be conclusion. Now, does that mean we should stick with Tesla? Does that mean Tesla is going to be 2 trillion? Of course, I can't answer that question with this, but this is not the point. The point is, the more you work, the deeper you go, the more you unravel the onion, the more to the core of the thing you get. And what this gives us is certainty and confidence that we're on the right path, that Tesla has the potential to get there, and that we should never forget the main advantage of Tesla is that they're rolling this out to hundreds of thousands of customers. This is unbelievably important. Nobody else is doing that. Nobody. The only company which is getting a little bit close is Waymo, but that's a very different situation there. This is like saying, Google has competition from, I don't know, a dedicated search site in the medical field, which is highly, explicitly programmed for a very specific problem. And there, maybe the search is better, but it's not general, and it's not, it's fully controlled, and therefore it's just not the same comparison. So other than Waymo, nobody else is shipping self-driving software at this stage. And I mean, just one little, and I'm going to finish. I'm way over my time slot, time allocation. But Ashok talks about, let's say, collision warning when a car rolls over a stop sign and then there's a risk of a collision. And he says, look, what's the difference between the Tesla collision warning system, and the typical ADAS? It's that ADAS cannot predict what the car in front of you will do, and therefore will act very statically, versus the Tesla system is actually very good at predicting the near future and therefore acts very differently. So those are subtle things that I think make a huge difference. Thank you.